we will, well, first of all, the people who didn't connect live can join us. And secondly, we will have a video that all of you can make use of. Okay, so just a couple orientation things first. You can see on the screen I have a message. By the way, I went without my camera. I'm having some memory issues on my computer. So anyway, sometimes I'll come on and you can see me and we can talk for a while, but most of the time I'm going to be sharing my screen similar to what I will be doing in class. Anyway, those of you who didn't get in the first 10, anybody can contact me. If you'll be in a YouTube live session and you can send me a message in there. It's just delayed a little bit on YouTube, but it's the same kind of thing. You just can't speak up. Welcome, Adam. And then the other thing you can do is you can just send me a text message to my phone. I've got a lot of things to watch, so I might be a little slow in responding. And I'm recording and I'm running all this. I got about 5 screens running right now. So anyway, navigating on here, if this is your first time, if you move your cursor to move it a little bit, you'll see this menu come down. And on there, you should see a microphone, which you can click to mute yourself or unmute yourself. There's a camera you can turn on and turn off. So if you want to speak up, just turn your mic on and let her rip. Ask me a question. I don't care if you interrupt. You know, if I'm going through something and it's not clear, it's fine if you just let me know. Okay, then this is it's kind of our first class, but and we only met briefly on yesterday. So I do want to. First of all, just remind you, and I'm going to change my screen here. I'm going to show you a different slide. First of all, in the syllabus, and I'm going to post this in a better way on the website, we've got this approximate schedule. So we're obviously in this week 1 thing up there on top. And you notice it's not very specific on lessons, but if you see on week 2, I'm supposed to be getting into lessons 1, 5, and 1, 6. So in other words, in this first week, concentrate on the lessons 1, 1 through 1, 4. Okay, because you can see, if you can see that in week 2, that's where we're going to be starting on lesson 1, 5. So I'm already telling you that when we're done today, I'm not going to give you a specific assignment, but you should be working on looking at the 1, 1 through 1, 4. And then the other part of the syllabus is what do we call them? The core exercises. Okay, so I see 1, 4 is skipped, so I'm sorry. Basically, you're looking at those first 3 lessons there, 1, 1, 1, 1, 2, 1, 3, and these are the core exercises. So look at those exercises from those 3 lessons. I'm not going to say you have to do them all, but I need you to be able to do problems of that type. So come with questions on any of those that you would like to talk about. I'm guessing we probably aren't going to do that today because we haven't had any lessons yet. But so I'll come back to this later. But before I forget, then after the session today, start looking at those first 3 lessons: 1, 1, 1, 1, 2, 1, 3, and then between our class tomorrow, Wednesday, and Friday, any questions on that? And then starting Monday, I'll start digging into the 1, 5 and the 1, we'll start on these next 2 ones down there. Okay, so that's a little bit of our plan of attack. Just one more reminder, anybody who is on YouTube, on the video section, which also works fine, you can contact me by sending me a text message, or you can use the live chat that's also in the YouTube. Okay, so the plan of attack for today is I've picked a topic. I mean, this is not any particular lesson of those first three, but this is so important to calculus that we need to begin here. So this should be a review, but I want to talk about functions and something called difference quotients. And you probably know this, but it's so important. I think it's where we need to begin. And one other thing I wanted to tell you, this recording, this video that we're making here, I will make that available on the Moodle site. I haven't exactly figured out where, but I think what I'm going to do is make a section for this first day. I'll have a couple links there, and I'll have the video link there, at least for the time being. Also, I'm planning on adding those 2 slides that I just showed you from the syllabus. That is the approximate schedule and the core exercises. Okay, so to get started with functions today, I just want to give a little tip of the hat to 2 mathematicians, actually 3, but we'll start with these 2. Leibniz on the left, a German. He's one of the discoverers of calculus, along with Sir Isaac Newton. And it's really cool how they discovered it simultaneously. And that, by the way, I'm purposely using the wording of they discovered calculus. They didn't make it or create it. I believe mathematics is the order out there that God has created along with his creation, and we just discover it small piece by small piece. Leonard Euler on the right, and here's another picture of Euler from Switzerland. There's so many cool contributors, but here's what's really huge about Euler. I mean, there's so many things, but if you see right down there, you know, this f of x notation, which hopefully you're familiar with, was first done by him. And that notation turns out to be extremely useful, as you'll see today. Okay, so let's talk a little bit about functions. I've got some slides from a textbook manufacturer, but most of them I'll be providing myself. So the difference between a relation and a function. And in this slide, we talk about a relation. Basically, a relation is any set of ordered pairs. I mean, any. So there's no rules whatsoever. I could just make up 20 points. I don't care what they are. That's a relation. So it's just a set of ordered pairs is probably the easiest way to describe it. Now, when it comes to a function, we're more picky. I'm sure you know that, but a function, there is a rule. You cannot have 2 points with the same x coordinate and a different y coordinate. So in other words, whatever you input for x, only one answer can come out. So for example, if I go to the store and buy a gallon of milk, and one of you is in line right behind me, buys exactly the same item. So I buy 1 gallon of milk, they charge me $7. You go through and they charge you $2. That would not be a function. So for every value of x, and of course the Americans would never stand for that. That would be unfair and would be discrimination. So with purchasing, that's a good way to remember. So a relation, they can do anything they want. There's no set of rules at all with the ordered pairs. But with a function, You can have a repeat X, but it better have the same output Y. Sometimes, so we have two more terms here. The X values are called the domain of the function, and the Y values are called the range of the function. And sometimes in books, you'll see they draw a circle for the domain and the range, and you know, each value over here in the domain maps itself over to a specific value in the range. So sometimes they'll draw it like that. It's not real important, but and other times they'll use rectangles instead of circles, but it's the same deal. For each X, there is one Y. Now, I didn't tell you, what you can have is two different, here, let me give you an example. Let's say we have this point, 1, 3, and let's say we have the point 1, 7. So there's a set of two ordered pairs. Is that a function? No, because the same X mapped to two different answers, and that's like the two different prices for milk. So now let me erase that second ordered pair there for a second, and let's put another one in there. So instead, what if I use 2, 3. Now we have a set of two other ordered pairs. Is that a function? Yes. We don't even have a repeat X, so we have nothing to worry about. Yes, so it's okay to have two different values of X having the same Y. What you can't have is two values of the same X going to two different Y's. So this is a function right here. The one I had up there before. No, it wasn't a function, it was a relation. So I think you guys know this, but we need to get used to that terminology. Now, sometimes we just have raw, here we go with some sets of points. And that top set of points, the book, as you can tell, it says that's a function. Why? Well, in those 4 points, you notice we don't have any repeats. We don't have any repeat X values. And again, we have this situation where we've got 2 points with the same Y. That's okay. You just can't have two repeat X's. And that's what's wrong with the bottom one in part B. Why is that not a function? Because we have 2 points that have the same X, but a different Y. And that's a violation, so not a function. Okay, I think you guys know this, but all right. Again, let me remind you, if you have a question and I've misspoken and you want to straighten things out, go ahead and speak up. All right, in this next slide, we see Euler's notation come out. We often use F, I guess F because it's the first letter of the word function, and then letters after it, like F, G, H, are frequently used for functions. And I know in the old days, you just had Y equals whatever. But the real advantage to the function notation, well, we look down here where I wrote, here's our function that we'll start with. F of X equals 2X plus 1. And by the way, I'm going to take my keyboard off here so I can write a little bit more easily. So we have the function 2X plus 1. And this notation right here means, well, what happens when you plug a 2 in for X? You see how the 2 literally takes the place of X. So that would be obviously 2 times 2 plus 1. So I just literally plugged in a 2 for X. And of course, I mean, we could just shortcut it. F of 2 is 5. And what I love about that is, that means the point 2, 5 is literally one of the points in our function. And what's F of 0? 2 times 0 is 0 plus 1. So F of 0 is 1. Again, that's the ordered pair, 0, 1. See how nicely this notation shows the ordered pair? That's one of its real strengths. And then what happens when we plug in a non-number like a? Well, that's 2 times a plus 1. And that's an ordered pair too. You may not like it, but in effect, that says when you plug in a, out comes a 2a plus 1. So function notation is really a big boon. It makes it a lot easier to do some of the things we're going to be doing. Okay, so here we have a function, and this is just a repeat. How do you find f of anything? Substitute that in. So if we want to find f of -2, take the function that you've been given and plug in a -2 for each x. Here we have x twice, so you see how it was substituted in both times. And then just do the arithmetic. So what happens when you plug in a -2? Eventually out comes a 9. That represents the point -2, 9. All right. Here's just another one. Now, sometimes we don't substitute in. I've already shown you a little bit. You don't substitute in a number. What if you want to find f of x plus 2? Then you have to plug in x plus 2 for each value of x. So you see how, and this is not corny now. You actually need to think of this physical substitution in those two places. You see here we have some extra work to do, right? Because we have to square x plus 2. And you guys know that's not x squared plus 4, right? You're going to wind up with a middle term when you do your handshaking, or those of you who haven't had me before, I use handshaking to talk about what most of you probably learned as FOIL. The problem with FOIL is it only works with binomial and binomial. Handshaking works when you have trinomials and any number of terms. So anyway, here it is squared out. It's got that middle term 4x. And then over here we had to do the distributive property. And then you just put everything together. Gather the like terms. Oh, so what happens when you plug in an x plus 2? Out comes, in this case, 4 minus x squared. And again, we have an ordered pair. Okay. Then the terminology again, hopefully you're familiar with that. The domain of a function is all the values of x that you can plug in and do things with. Which I know seems silly, especially with a function like this one. I mean, what can't you multiply by 3 and add 5 to? Well, the answer is nothing. You can do that. You can triple anything and add 15 to it. So that's why the domain in this case is basically anything, all real numbers. The real numbers, by the way, I would say 98% of this semester we're going to be talking about the real numbers. Yes, there are valuable things with the imaginaries. It's just that for calculus, we won't be doing much of that. Okay. On the other hand, if we get a function like this one, the square root of x minus 3, x can't be just anything. And the reason is, if, for example, if x was 2, we've got a problem. 2 minus 3 would be -1, and at least in the real numbers, we can't take the square root of a -1. So the domain here is limited. It can only be, what, 3 and above. And so if you look down on the bottom here, there's 2 ways to answer that. You could say all values 3 and above, which is what this says. And this is what? Interval notation here on the right. The square bracket means include 3, and the round bracket means up to. I know infinity is not a place, but still, we always use a rounded parenthesis for infinity. So how did I find that? By the way, is 3 okay? Is x equals 3 going to work here? Yeah, because you get square root of 0, and that's legit. The square root of 0 is 0. So, and how can you find out? Well, just say, well, x has to be 3 or bigger, and you can find out real quickly. Oh, there's your domain. All right. So a little practice with function notation here. If the function we begin with is 3x minus 3, written in function notation, that's f of x equals 3x minus 3. And then we can play around with different individuals, like what would f of negative 3 be? So you substitute it in, you plug in a negative 3. 3 times negative 3 is negative 9. Negative 9 minus 3 is negative 12. We've got it. F of negative 3 is negative 12. And then you can plug in something like x plus 1. How can I find f of x plus 1? Substitute x plus 1 in place of x. And then in this case, you can't come down to a number. The best we can do is, after simplifying, we get a 3x. So here's the ordered pair for that. And then way on the bottom here, what happens if I ask you for f of triangle? Substitute in triangle in place of x. Or delta, whichever, those of you who previously had delta x, this is that Greek letter delta. Okay, so one more slide from the textbook, and this is back in the domain again. Do we have any domain issues here with this function? Well, we sure do. You guys all know that as soon as you have a division problem, you cannot divide by 0. So right in your head, right away, you should say, whoa, x squared minus 1 cannot be 0, which is, so when will it equal 0? Oh, well, remember this is factored as what? The difference of two squares. Remember that? A plus b times a minus b is equal to a squared minus b squared. I hope so. And then you set each factor equal to 0, and you get there are two things that would cause this to be 0. Therefore, the domain is everything but that. So what this says is it can be anything except 1 and negative 1. So okay, so that domain is a huge deal, because if you don't restrict it, you can wind up with totally illegal and incorrect answers. So I know, simple, you probably had this in your Algebra 2 class in high school, very important. Okay, so now we're going to spend the rest of the time talking about something called difference quotients. Difference quotient. Because this is the root of what? The whole this whole Calc 1 semester, being able to do a difference quotient. And a difference quotient is actually just another name for, I'll tell you what, would somebody that was in my pre-calc class or anyone speak up? What's a substitute for a difference quotient? What's another way to say that? You may have to unmute before you answer. A difference quotient is just another way of saying what? Okay, I put you on the spot. It's just a slope. Good old slope formula. So, but you'll see why it's got a special name, because it's a better description for calculus. Okay, so I got a little grid here, and I've made I should have made this a different color. There, now it's red. We got some generic function. It doesn't have to be straight. like it is in this case. But you've got a generic function here. And I'm going to pick two generic points. This one, I'm going to say, oh, I'll be real original. Let's call the x-coordinate x. And over here, then we're going to move over h units to the right, and that'll be the second x-coordinate, x plus the h. What are the y-coordinates? What is f of x? Well, you just plug it into the formula, and you get, in this case, the best we can do is the y-coordinates f of x. And what happens when you plug in f of x plus h? You get f of x plus h. Okay. So, do you remember how to find slope? Hopefully you remember this formula. Right? Or you might have learned it as delta y over delta x, change in y over change in x. So, I mean, this you could call our point 1. This one over here we could call our point 2. So you just plug them into the slope formula, and what do you get? Take the second y. I got to shift this down a little bit so you can see it. So you take the second y coordinate, y2, f of x plus h, minus the first y coordinate, f of x, and divide it by x2, that's x plus h, minus x1. You know, what's x plus h minus x? H. So when you simplify it, here it is. This is just a slope formula for this generic drawing. It's also, more importantly, called a difference quotient. So let me just pause for a minute. So all I'm doing is taking the second y coordinate minus the first y coordinate and dividing it by the second x coordinate minus the first x coordinate. And you get this expression. I put it in a box because that's a generic difference quotient. If you're not familiar with that, you need to be familiar with that. So what we're going to do for the remaining, I don't know, about 20 minutes is I want to find a bunch of difference quotients. We're going to propose some functions. I'm going to give you some made up functions, and we're going to together find the difference quotients. Pre-calc people, you know, I hammered on this, and I need to hammer on it one more time here so we're ready to go for this course. Okay, so that thing in the box, you definitely want to know that. So if you're taking notes, you want to get that down. Now, in the book, instead of calling it h, they call it delta x. It's the same thing. Delta xy, because it's the change in x. So some books will do this notation, some will use the delta notation. I will use both, so eventually, so you're familiar. But right now, I'm going to just focus in on the h. All right, so now let's basically find, this is a repeat, so we don't have to go through that. But let's take a function like this simple one, and let's find, here's the function, find the difference quotient. That's our task. So, kind of problem I need you to be able to do. All right, well, that means if you look down in the bottom, I need to do this, right? This is that thing we just had in the box. Well, if I'm going to figure out that, I already know what this is. That's right up here on the top. But I don't know what this is. So guess what the first step is? In this problem, let's find f of x plus h. Again, how do you find f of something? Substitute in x plus h in place of the x, which is what you should see that I've done right here. Well, and then just multiply out the distributive property. So here's our f of x plus h, 2x plus h minus 1. So now just substitute it into this thing down on the bottom here. take the f of x plus h, this thing, and from it subtract the original function and put that all over h. So I'm just literally substituting into this difference quotient formula down here, and then just simplify. And I mean, you should be able to see that we can come down to 2. So the difference quotient for this function is 2. Okay, that was an extremely easy one. And by the way, should that surprise you? By the way, all a difference quotient is, remember, is just a slope. Now come back up here on the top. Look at this equation one more time. What is that? What kind of an equation is that? Linear, right? Oh, it's a line. And can you tell what's the slope? Oh yeah, you know, it's good old mx plus b. The slope is sitting right there, right? 2. So does it surprise you that we got an answer of 2 down here? That should make sense to you based on good old slope-intercept form. Okay, so that was a pretty easy one. Let's take one. Let's do another. So this time, we're going to take a little bit more complicated function it's got a square in it. So this time our function is x squared minus 7. Again, your mission, should you decide to accept it, is to find the difference quotient. Sorry, bad humor, mission impossible. So this is what we're trying to find. Again, I don't know what f of x plus h is. So guess what? Always the first step in all of these problems is find f of x plus h. So you see how I substituted x. Please note, f of x plus h is not x to the 4th minus 7. You know, it's not just, it's not just x squared plus h squared. What happens when you square a binomial? You get a trinomial. Trinomial. So anyway, you hammer it out. And so here's underlined in red, there's our f of x plus h. So now substitute it into our difference quotient, f of x plus h, and then subtract the original function. Notice I did it in parentheses. These parentheses right here are incredibly important. And then divide by h. So after simplifying, here's why those parentheses are important, that when you subtract a negative 7, you actually add 7 and the 7s go away, right? You come up with this. And that's correct. It's just that, notice we can simplify there. We could factor in h out of the top. And then that h will cancel with that h on the bottom. There it is. There's our slope. So now, this is remarkable because before we had a linear function, the slope, easy, mx plus b. But there is no such thing as an easy slope from a quadratic, a x squared. Well, you just found it. And I know what you're thinking. Well, I don't know what x and h are. That's true. As soon as we tell you what x and h are, though, you could go in there and you could find it. So anyway, all right. Hopefully you're with me. Notice now we're going to make it a little bit more complex. So this time we're taking a trinomial. So here is our made-up function. Again, you and I are to find the difference quotient. Okay, so that's the task. Just now remember, that's that f of x plus h minus f of x all over h. So I've got to find that f of x plus h. So here we go. We substitute x plus h in wherever there was an x. So I had to substitute it in twice. I'm not going to take the time right now to hammer it out, but you would have to do that. Again, we have a trinomial in here. In this area, we have a trinomial. And then finally, when I simplify the whole thing, here's my f of x plus h. Yeah, it's kind of messy. They're going to get messier when you have a messier function. All right, so now take that and subtract f of x from it. And this time I'm using the vertical format. I'm taking the function up here, and I'm literally what? Subtracting it. So minus f of x. The vertical format works nicely because now, you know, good old vertical subtraction, the 2x squareds go away, the minus 3x's go away, and the 2's go away. And what's left? 4xh plus 2h squared minus 3h. Here I actually showed you the horizontal way to do it. But so to simplify it, it comes out to this. And you're going to notice that always you want to get to the point where that h is gone from the denominator. And guess what? You're always able to what? Factor in h out of the top. So h comes out of the first term, the second term, and the third term, and here finally is our difference quotient. Anybody want to speak up? I haven't had, or I don't know, not seeing any. Let's see, we did have one person have to drop out. Hopefully it wasn't for.
What did you do in the blue writing?
Okay. In the blue writing, I was doing this. So, you know, that part of the thing where you have to subtract the original function, f of x. So if you can see up on the top, this was the original function up here, right?
Yep.
So do you see how I'm just subtracting f of x from that f? See,
oh,
here,
yeah.
So, but I actually did a vertical subtraction. Here I did it horizontally down here. I don't know. For longer functions, it's kind of a nice format because it's a little easier to see.
Okay.
Thank you for asking. Anyone else while this is still up there? So I actually did that subtraction two ways here. Maybe I shouldn't have, but yeah, I like that vertical format when you have a longer, messier function. Anyone else? Thanks for speaking up. That's the kind of clarification I'm glad you asked about. Okay, let's go on to another one. You can probably tell I'm kind of moving up in complexity each time. So there we had a longer function. This one's not very long, but guess what? It's our first fractional function, or where we have 1 over x squared. So this just creates a little more challenge. Once again, we know we have to find it's g of x, but we know we need to find what? I don't have it written here, but we have to do that g of x plus h minus g of x all over h. That same difference quotient. So guess what? We've got to find g of x plus h first. So same deal. Plug in x plus h wherever there was an x. Well, there's only one. So here's my f of my g of x plus h after you multiply it out. All right. So now this looks a little worse, I know, but in black, here's my x plus h function, and here's my original function. So that's the f of x plus h minus f of x all over h. So yeah, I know. Now we have a complex fraction, don't we? So what are we going to do? Well, I really need a common denominator so I can subtract those two fractions on the top, don't I? Here, I'll just cover up. We're not looking at that bottom right now. So you know how that goes. Common denominator. The first fraction, I need an x squared. as a factor. So I have to do top and bottom by x squared. The second one, I need the other denominator. I need that x squared plus 2xh plus h squared. So I multiply top and bottom by that. So what does that mean? All right. Well, I mean, first you should be able to see that this is my new common denominator, right? X squared times x squared plus 2xh plus h squared. And by the way, you're better off leaving it factored. On the top, I've got x squared times 1. That's this. And over here, I just have minus 1. So I just have to carry the negative 1 as a distributive property, and that gives me that. And when you simplify those, what's x squared minus x squared? Well, no x squared, and I just have this left. And the bottom, I still have this x squared, this common denominator. Now, what I've been ignoring yet is we still have an h on the bottom. You know? Okay. Yeah, you might have to look at this a little longer. I mean, this is a little bit messier. So what happens when you do one fraction divided by another? You invert and multiply, right? So this divided by h over 1 becomes times 1 over h. And here it appears. When you multiply by 1 over h, the h now appears in the denominator. And you notice I can factor an h out of the top. I didn't show that, but you see how both these terms here have an h. So if you take an h out of there, that h will then cancel with this one. And there it is. I know you're not going to think it's very pretty, but there's my difference quotient. Okay, I'm going to pause. That one's a little bit on the thick side. Anybody want to ask a follow-up on that?
Do the last step again, please.
Okay, the last step is, actually I didn't show it, but what I did is I took this numerator and I took an h out. I factored it like this in red.
Yeah, yeah.
And then the h's canceled and this over here results.
Yeah.
So I'm sorry I didn't show that, but I was kind of running out of space. Yeah, good question. Anyone else want to? Okay, we're at 8:42. We can probably do one or two more. This one is not more complicated. This one actually is a little bit easier than the one we just did, but let's just do it for an additional practice. So here we have another polynomial function, and we need to find the difference quotient. So same old deal, we got to find f of x first. I'm sorry, f of x plus h. So it's a little messy because what? You have to substitute in x plus h twice. You know, because there were two x's in the original function, so you make that substitution twice, and you need to hammer that out, and that's what I've done there. So there is our f of x plus h. All right, now let's subtract the original function. So I can't remember who asked me before, but this is that vertical format. Okay, so here's, all I did was copy this down here. And this line is just the original function. And you notice how I placed the terms right underneath, they're like terms. So that makes it real easy to subtract. So what do you get when you subtract that? You get this. Okay, I can't forget that I have an h on the bottom. And then real nicely, h factors out of the top. And we've got our difference quotient. So backed off a little bit. This is this one I would say it's not as messy as when you have a fractional function. still, yeah, it's a fair amount of calculation. All right, let's do one more. That's fairly, I'm going to just see what else I have here. Okay, I think we'll do this one. Let me introduce a little cover up here so we can take it one step at a time. So instead of variable x, sometimes you'll see a different one. So like here's f of t. It's the same deal. It's just t is used in place of x. So a little bit harder again. Here's one of those fractional functions. 1 over t minus 2. Your mission, I mean, just change again. That's the difference quotient. But instead of x, you see we use t. I mean, it's the same thing. So well, guess what the first step is? The first step is, this is always the first step, right? We got to find this guy. Yeah, it covered up there. You got to find that guy. So that's step 1. What is f of t plus h? No big deal. Substitute in t plus h for t. We're done. There it is. 1 over t plus h minus 2. So that was not hard. Now, here's where it gets a little bit ugly, because now we got to subtract f of t plus h minus the original function, and we got this fractional subtraction problem again. By the way, you can see here vertical subtraction wouldn't work at all. Or it doesn't help. Excuse me. So we have no choice but to get the common denominator to get this thing together. And so just like before, the first fraction needs a t minus 2 factor. The second fraction needs a t plus h minus 2 factor. So you see in blue how I've multiplied top and bottom by what we need. Okay, yeah, we got the divided by h. I just haven't gotten to that yet. So this results in this line down here. I mean, you multiply t minus 2 times 1 and you get t minus 2, and you multiply t plus h minus 2 times this. Don't forget that, notice I put, these are very important, these parentheses, because when I subtract all of that, that's going to change the signs, isn't it? And what do I have on the bottom? My new common denominator. Okay, so what is t minus t? The t's go away. What's negative 2 minus a negative 2? Those go away. What's left? Minus h. Does all of you see how the minus carried over? So that's very important. And then we still have our common denominator. Okay, I didn't show you, but where did this come from? Well, remember, that's this same h that way up here on the top and way over here. If you divide by h, you're multiplying by 1 over h. So that's where this came from. And then, beautiful, you see we have a cancellation. We can't ignore the minus sign up there, though. Right? I mean, there's a 1 left, but it's a minus 1. And finally, we have our result. Questions on that one? So we're pretty much at our 50-minute limit. I just got about a minute left. So what I'm going to do, and I just want to remind you that that back on the schedule, this week we're concentrating on lessons 1, 1, 2, and 1, 3. We're not doing lesson 1, 4. And then next week we'll start hopefully on lesson 1, 5. So as you concentrate on lessons 1, 1, 2, and 1, 3, these are the problems that you should be looking at. I'm not going to say you have to do every one of them, but those are core exercises. That means those are the kinds of things you would be expected. You need to be able to do those. So what my kind of indefinite assignment is, work on those problems from 1.1, 1.2, and 1.3, and tomorrow come to class and bring any questions you have. And we will continue to work on those 3 lessons this week. So a little bit indefinite, but that, and last year in pre-calc I spent a little more time on review. We will not, we can't this year. Questions before we hang it up today?
Is that core exercises sheet on Moodle?
It is, but what you have to do is open up the syllabus. It's in the syllabus. But what I'm planning on doing is I want to post this also so it's visible right in Moodle. So but right now, if you just go onto the Moodle page, click on syllabus, you'll see this is in there.
All right.
Thank you for the question. Other questions? One more comment I have, and that is that when I stop the broadcast, I will be publishing the link to the video on the Moodle site. I don't know exactly where yet, but it should be in a real obvious spot. Okay? So then if you want to go back and look at any part of this, you can. All right. Thank you for joining me, all of you. I appreciate it. And I look forward, I'll see you tomorrow.